Screen share, full screen. All right, so we have about an hour and 20 minutes of official class time left, we'll probably get about that far. So what we're going to do is I'm going to introduce this concept because I still haven't introduced the concept. So rather than usually when we start in the lab, we've already talked about the concept. I'm going to introduce this concept of an array and then talk about how we use it and how we can get our data in and out of ArcGIS using an array. So this is also a really cool tool for being able to interface with other products because there are so many formats that will allow you to read and write into a basic array that sometimes doing this method can provide a shortcut for interfacing with a different computer program like image processing or really anything else in the GIS world. So I did, it's got big again. I did put a script up on GitHub that I'm going to start off with. So it's under courses, week 10 for me, but not in there. It's just in here. Week 10. I just called it example 1. I'll start with that. I'm going to edit it in IDLE. You can get it off of GitHub if you want. And I'm going to explain this really quick. So, and as I do, I'll pull up a few more windows before I actually run this. So, of course, we import ArcPy. The second thing, we import this thing called NumPy. What does that mean that NumPy is? Some other what's that? Right, it's some other module, and it actually does stand for numerical Python. And it is a module. It is one of the free modules that's developed by people that are into open source, and it's developed right alongside Python. So Python itself doesn't have the ability to work with arrays, but numerical Python or NumPy is what gives Python the ability to work with arrays. And so doing everything in just pure Python will be slower if you're just using always lists. So an array is a lot like a list, which we'll see in a little while, but it has some key differences, right? So we're importing that NumPy, and NumPy will install with ArcGIS. So ArcGIS, when it installs Python. You probably realize that by now. And it installs several packages. NumPy is just NumPy or NumPy is just one of them. So it installs one called SciPy, which SciPy and NumPy are actually developed by the same set of people. SciPy just extends it even a little bit further and provides routines for doing like multivariate regression and just actually plain old regression. Lots of math things that you would want done. SciPy does. So if you want to use, we'll actually introduce a few more of the modules that are included with Python with the ArcGIS's version of Python next week. That's the last lecture. But SciPy is one of them. We'll talk about it a little bit more next week. There's one for plotting data, for creating graphs. That one's also included. It's called Matplotlib. That was created by actually another university professor created that, and he actually recently passed away. The guy who created the plotting library, but people have carried his work forward. It's a really great tool. We'll talk about that all next week. So NumPy or numerical Python, if you go to the web and you just type in NumPy, you'll get a You just type in NumPy, you'll get a URL. So this is the kind of landing page for NumPy or numerical Python, you'll notice that one of the buttons is take you to scipy.org. So scipy actually uses NumPy to do its work. You can't do advanced mathematical operations like regression without first having arrays to work with. So it's the fundamental package for scientific computing. Okay? So it does these things. It has a powerful n-dimensional array object. That's not available with Python. That's the one I've kind of already covered. The second one is that it says sophisticated broadcasting functions. All right, what does that mean? Well, broadcasting is kind of like what we would call in the ArcGIS world raster functions. They don't call them that because they don't call them rasters, but they're array functions. They're things that you can do to a whole array, or that's what we call a local function. You do it to a whole array cell by cell, or you could do something where you say, I want the average of this entire array. And so instead with a list, you actually have to say, for I in list. So you remember when we built our averaging functions, we calculated the average. There's a numerical Python thing. It's called mean, I'm pretty sure. So you just say, if the name of your array is Bob, you say bob.mean, and you get the mean of Bob. Okay? So sophisticated broadcasting functions. You can even do focal functions to calculate the neighborhood mean and smooth and all sorts of things like that. It's interesting. Numerical Python is actually written in C or C++, so it's not written in Python. But you still write in Python code. You're just implementing. Python itself is written in C and C++. So I guess that's just a byproduct of that process. I mentioned regression, all sorts of other things, linear algebra, Fourier transform, random number capabilities. We'll actually talk about that. All right. So here is the getting started page. You don't really need to install it. It's already installed on your computer. But if you hit this NumPy and SciPy documentation page, and you can get I don't know why you'd want to. Yeah, you find something to go to sleep to. It's difficult to just like navigate through it. I think it's better to search it. So oftentimes, like let's say I want to sum NumPy array. Okay, then it pops up that this is from the manual rather than having to find where it was in the manual. That's the manual that I just showed you. You click on it, and here is how you do that. So you say NumPy.sum, you give it the array. So actually, I said the name of the array .sum. It's actually not like that. So the Pythonic way to say that is the name of the package .sum, and then you give it the name of the array. Okay. There are some options that we're not really going to talk about right now, but if you wanted to get into it, you could look into that more. One of them is the axes. So let's say you only wanted to look, if it's a multi-dimensional array, and you wanted to sum it across one of the axes, you could do that. So if you wanted to sum it across the x-axis, then in our case, we have an x and a y axis. You sum it across the x-axis, you get the sum of all of the x-axis. So you get the sum of all the columns of the data. You end up with a long, I don't know why you'd want to do that, but there's definitely applications for that in other fields. Okay. All right. So we'll provide a few examples of this. Yeah, so here's some examples. Okay. What's interesting is that NumPy allows you to also feed it lists. So it still has to do conversion, so it takes longer. But it does the internal conversion between a list and an array. So it'll create this as an array if you feed it a list. And one thing that you can do, I forgot the name of the function, but there is a function. I think it might just be numpy.array. But you can feed it a list, and it'll give an array. Let's see what that is. Numpy list to array as array. That's what it was. So here is the syntax. I've got a list, and I'm going to feed it to it as an array, and it'll turn that value into an array. Okay. All right. I wonder how to create a two-dimensional array, but we can experiment with a few of these things. So let's go back to my script here. My script is doing something really simple. It takes the NumPy module and it uses this random submodule, and then it uses this function called random integers. And it's going to create a bunch of random integers from 0 to 100. And it's going to create 2,500 of them and put them in an array. So let's actually look at what that looks like. My array. I'm gonna block out these two for now, or these three. 1, 2, 3. Okay. I'm gonna run this. So what I've done is I've created created an array with a bunch of random numbers. If I run this again, I'll get different numbers because they're random, or I should get different numbers. Here I won't. Okay, I will. All right. Sometimes you have to sometimes on random number generators, depending on the programming language, you have to reseed the random number generator. So evidently you don't here. But the random number generator has created those arrays, and one thing that that NumPy always does is that if the array is more than a certain length, it'll only print the first three and the last three and give you a dot, dot, dot in between. So we could change this to 10, and I believe it would just print the okay, it's not letting me do this part. Okay. I'll explain why in a second. So now I've got just 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. What's the square root of 10? It's 3.1. It's hard. Okay, yeah. 3.1 something. Well, one thing we could do is we could make a row of, we could make 3 rows and 10 is divisible by, we could make two rows of 5. Okay, so that's what this line is doing. It's taking an array and it is converting that shape of that array to, here it was converting it to a 50 by 50 because 2,500 was 50 times 50 square root. So now if I change this to 2, 5, it will run and, what's that?
Give you the whole thing too, huh?
Oh, I need to print that one. Now, yeah, and it'll give me the whole thing. Oh, okay. I can't, yeah, right, my array. Okay, so another thing about an array that's like a list is it's mutable. Okay? So we can change individual values, and this function actually changes those values in place. So my array.shape will change those values. And you can see down here, the notation looks kind of like a list. One difference is there's no comma. Okay, so that's really probably the only giveaway you can get. But it looks like a list of lists, but it is now a two-dimensional array. And you can see that that's
the matrix from algebra.
right. It is kind of like a matrix. I mean, matrix algebra is different.
Yeah.
Not SciPy can treat two arrays as matrices, and add them as the matrix. Add them to do normal matrix algebra with them. We could create a three-dimensional array. Let's see. What would, if I change this to 25, would 2 times 2 times 2 is what? Let's just do that. So maybe that's still not picking right. Yeah, I guess so. That's still not right. It's 2 to the third. What's 2 to the third? Oh yeah, you're right. It didn't. Anyway, it's hard for me to.
2 sets of 2 by 2 is what's given you.
Yeah. Anyway, we don't need to think in 3 dimensions. Sometimes it's hard for me to think in 3 dimensions. So let's say this at 10, or this would have to be 4 now. Let's go back to 10 and maybe 25. That's better. 5 by 5. Okay. So now this is going to run, and it's going to create a 5 by 5, 5 rows, 5 columns of data. There are tools for, we could change this up. There are tools for creating an array of zeros. So we say numpy dot zeros and give it 25, and now it will create a empty row of zeros. Ones. All right, now you might say, oh, is there one called 2s and 3s and 4s and 5s? No, they're not, okay? Now that's why we start getting into math. So we could just go like this, and we would get all 5s, right? Okay, so the math that happens to array is almost exactly like the math that happens to rasters in raster calculator. The cool thing is that it happens a lot faster, like 5 times faster. And so we've taken all of the numbers in the one, and we multiply. We've taken about a data set. We create a data set of 1s. We multiply it by 5 times 5. We reshape it. We print it our array. That's what that is. All right. So now. What does this have to do with ArcGIS? Well, there are 2 functions. The first function that we're going to talk about, maybe this is talking about it in the reverse order of what we should, is called NumPy array to raster. What NumPy array to raster does is it converts a NumPy array to a raster. It goes that way. All right. Now, with a raster, how do you georeference a raster? Yeah, how many coordinates do you need to georeference a raster? Well, okay, if you didn't have any other information, you'd have to have 2. If you have the cell size, how many would you need? Just 1, exactly, right. So to georeference a raster, and the way ArcGIS wants you to give it to it is it wants you to give it a single point, and it wants the cell size. And you can feed it the X cell size and the Y cell size, but if you only feed it the X, it will assume that that's also the Y cell size.
Square. What is it?
Yeah, and almost always cell size are squares. I mean, it's really more easy to deal with square cell sizes than anything else. Okay, so I'm going to uncomment out this next line. So what this is doing is saying, okay, I'm gonna create a point, and that's going to be my location. I'm going to pull up the help here real quick so that we can see. Or I should have said arcPy. And then should take caps lock off because I hit it with my phone. Okay. So this is the NumPy array to raster help. I just Googled arcPy NumPy array to raster. Okay. So these are the parameters. The only one that's required is this first one, the in array. Everything else, the ones excluding brackets, are not required. So what this does is it takes, you give it the name and it takes an array. That's the first parameter. So you give it an array, and then you can optionally feed it all the rest of this stuff. If you don't, I think the defaults will show up. The default value is none. So my guess is that means that it puts it at 0, 0. So you need to give it the lower left corner, and you need to give it the X cell size. Let's see what the default is there, because that's also optional. The default value is 1. Okay. So almost all the time, I've never found a reason to use any more than these two things: the lower left and the X cell size. So it'll set it to 0. Okay, so let's practice. So I'm going to run this. Oh, I got to uncomment out this and uncomment out this. So now what it's going to do is it's going to create this random, or not random, this grid, this 5, 1, and it's going to create a 100, 100, wherever that is. And then you would give it the name of the array, the lower left corner, which is 100 and 100. One thing that's interesting is that this uses a slightly different syntax than you've ever seen before. With optional parameters, typically the way Python handles it is that you don't feed them in order. You feed them the name of the parameter equals and then the value you're trying to feed them. So we have it say lower left corner equals point. And this says X cell size equals, it says 1. But do we even need to put that there? No, but I did. Okay, so now I'm going to run this guy. And I'm going to go to ctemp. I'm going to wipe this guy out clean. What's that? I'm going to go to ctemp, my random raster is right here. Okay, so there's my random raster, and it's not really random because I forgot to uncomment out my code before. But let's just inspect and see. All the values are 5s. Yep, all the values are 5s. All right, looks good. Let's rerun it. I'm gonna remove it, otherwise it won't rerun it. But I'm gonna go comment out. Actually, I'll save this here so that it'll still be there for later. I'll X this out. I'll save that there in case you wanted to have that. So now I'll run this again. Hopefully it'll allow me to save over it. Oh, did I? Oh, override outputs off. It's not a big deal. I wish somebody would Give me the gift of spelling. All right. I think it was like a week or two after I got here, and this is really bad to admit, right? So, you know, I know how to spell really basic words like there, right? But I don't think I really cared until I got here. You know, like, so, you know, 13 years ago, I was talking to Cochran, and Cochran was making fun of some student for not spelling there right. So I went back to my office and I read the definition. Oh, okay, I can do that. Got it. All right. So, okay, so let's look at it. It ran, and my random raster. Okay, so that's what it did. That's what it did. Create a bunch of random values. So there actually could be an application for creating a random raster if you wanted to compare, you know, something to random. It would work. I think there is a tool for creating a random raster. Okay. So it's not like we've done anything revolutionary yet, but a tool for creating a random raster didn't exist forever. Okay, incidentally, why is this colored?
To represent different values?
Yeah, it's to represent different values. Okay, maybe that was a bad question. So I'm gonna change this to 25,000 and change this to 50/50 again. And call this my random raster 2 and run it. And it's gonna be big. It's gonna take a few more seconds, but it is all done now. And I'll add that. Yep, that's all I did. Okay, so now, look, it's huge. I'll pull my random raster up on top. Okay, it's not colored. So this isn't really detrimental to this class, but just to give you some refreshers on raster or GIS if you've learned about it before. By default, anything that has less than, I think, 30 values is brought in as a categorical table. I mean, categorical raster, which means it has a table. And if it has more than 25 values, it is not considered a categorical value. Yeah. Which one? There it is.
There. Oh, okay. I don't know. It'd be an interesting Rorschach test. Let's go to, let's see squares.
Okay. So one more thing I want to demonstrate before we get off this topic is changing the point here and changing the cell size. So let's change the cell size to 10 and change the point to and let's change this back to 25 and 5. Actually, what will this do if I don't change the point at all? I'll call this my raster 3. What's that going to do? See if it gives me an error. No, it doesn't give me an error.
Smile on his face.
No. I probably just changed more. 5. Did it give you an error, Bryce?
One of the times I did it, I didn't change my array.shape. I left it at 5.5 when we did the 2500.
Right.
And gave it some error about not being able to do it.
Yeah, that's what I was just pointing out. So, okay. Yep, definitely. So I'm going to add this back in. What I meant is that it will make it 10 times larger. So since 5 by 5 is 10 times larger than a 10 by 10. So now it's the exact same size. So we scaled it up. See what I'm talking about? So there are 100 cells in each 100 cells in this raster in each of these cells. Okay.
So you kind of made it a different cell size.
Yes, I changed the cell size right here, but I kept the point the same. So now, though, I'm going to change the point to, let's change it to 50, 50, and run it again. Remember, I have to keep changing the name each time I run it because it's open in ArcGIS. So now what's it going to do? What's that? Yeah, exactly. Add this guy in, and the random raster 4, and I save it out. Where did I put it? 50, 50. Oh, because it's 50 by 50. Because 5 times 10, the cell size is 10. So this was 100, 100, and I moved it. I moved it 50, 50, and it's 50 wide. So I put it right there. All right, so my back hurts. My neck. That's more appropriate. All right, so we've shown NumPy array to raster. It'll take a NumPy array and convert it to raster. Maybe I should have started with the second one that we're going to talk about. There's another one called raster to NumPy array. What do you think it does? Yeah. Do you think you need me to change, show anything else down there on the coast?
No, I think you got it.
Okay. It's getting dark down there, it looks like.
Yeah.
Yeah. At the beginning of class, I can kind of see the disco ball and other things, but now it's just blackness. All right.
Freezing in here too.
It's freezing in there? You know, my office is cold right now. All right, so yeah, the opposite one is raster to NumPy array. So really, the workflow of most of the things that I do when I'm doing this is that I'm taking an ArcGIS raster or rasters and converting them to NumPy arrays and doing the math as NumPy arrays. And if you're doing this with very large data sets, it's often much faster to do it in Python. In Python as an NumPy array, rather than doing it in ArcGIS using the raster calculators, just raster. However, I do want to point out that I could do it to just change a specific value, because I can still reference a specific value. Let's take this data set that we just created, for example, this my random raster 4. Let's open that back up because now that's a TIFF. So I'm going to say File, New File. So we can save this, File, Save. And now we're going to do the opposite operation. So I'm still going to import ArcPy and NumPy. I'm still going to overwrite the output. By the way, I was going to mention this. What about projections? What projection is this in?
It's not any right now.
Right.
Anatomy of the maps is like no spatial reference. Just kind of
Yeah, exactly. That's exactly right. So it's not in a spatial reference. You have to handle that still in ArcGIS. There are tools. There's a tool in Toolbox for defining spatial reference. So if you wanted to define a spatial reference for this data set, you would have to do that as a tool in our toolbox. We'll dispense with that for this class. You know how to run a tool in our toolbox now in Python. You just run that. Alternatively, you know, if you're working with a bunch of data and it's raster, it really should all be in the same projection before you even start. And so when you're reading and writing these files, as long as you're continuing to use the same lower left coordinate and cell size the whole time, you could be working on your project for a long, long time. And then finally, when you're done and you actually want to show your data with other data, then you can just go define the data sets, define the projection for that data set. You can even do that in ArcGIS rather than doing that in Python. So two data sets will overlap, even if they're not defined projections, as long as they're the same lower left coordinate. Okay, so I'm going to, so this is NumPy array to raster. We're going to go raster to NumPy array. Here's a code sample. Now you have to do, or you wanted to usually do a little bit more NumPy array to raster. That's right. So look at what they've put in here. They've got an array that goes in, and then oh no, that's the one we're doing. This one, raster to NumPy array. So they've got a raster that's going in, and then there's another option to set a no data value. What are the other options? Let's look at the options. That's what we should have done here. Raster. No, that's the not. Raster to NumPy array. That's the one that we've been doing, right? No, that's something. Okay. I'm trying to think of why you would need to feed it the lower left corner. Oh, okay. I should have just read the help better. So the lower left corner within the raster from which you want to extract the processing block and convert to an array. So you don't have to just give it the whole array. So I rarely do that. So if you don't specify the lower left corner, it's just going to do the entire raster and turn it into an array. Okay. Number of columns, number of rows, the default is none, which is the whole thing. Okay, so yeah, the no data value. So ArcGIS, does anybody know what value ArcGIS actually uses for no data? Yeah, it's most of the time, it's actually what Nicole just said. 9999. No. And it's negative 9999. Okay, but not every format is like that. In fact, I'm pretty sure IMG is different, but I'm not positive. But in any case, this function here allows you, I'm just going to copy and paste it, allows you to convert whatever the no data value is in natively in the file format. As you're creating the array, you can specify what you want it to be. So you might not want it to be negative 9999. You might want it to be something different, but you can specify that at that point. So here you're saying I want my no data value to be 0. They can be something different. Okay, so let's do this. So we've got our in raster though. Our in raster is going to be that file that I just talked about. Let's look at my other file. It's going to be 4. So here's my random raster 4.tif. So that's the one I'm going to choose. So I'm going to say in ras equals, that's just the name of a variable. Just to prove that it worked, I'll say print ARR. So now I've got this script, and all it's doing is converting the random raster I just created from an array back into an array and printing that array. Okay. I'm going to have to call this example too. So here we go. Okay, so now I just printed it again. I mean, it didn't really do anything much impressive, but it's converting it. What I want to show is taking in RAS and converting one of the values to a different value. So let's say that we want to convert a 93 to 94, or no, let's say we want to make it 0. So in raster, what would that be? Is it rows and columns or columns and rows? Well, we'll find out. I'm sorry, array. The row is row.
Where it defines ARR, is this supposed to be equal to 0 at the end or hyphen?
This one?
Yeah.
That's an equal sign. It says no data to value equals 0. Okay, so I think it's 1 comma 4, 0, 1, 2, 3, 1 comma 3. I want to change that to 0. So I'm changing the value of that row and column to 0. Oh, so it's the opposite of what I said. 3 comma 1. See that? 0. It used to be 93, now it's 0. Okay, now I want to save that back out into a new file. I can do that. Okay, I'll call it my raster 5. Okay. All right. However, so yeah, bracket, those are brackets. So just like a list, you index a list, but you index an array. Lists are always one-dimensional. Lists can have lists of lists, which kind of is making them two-dimensional, but you still have to access each of their dimensions in separate brackets. Arrays are truly two or three or n-dimensional. They're n-dimensional. All right, so I'm opening this raster. I'm just changing one of the values. I'm printing it, and then I'm going to save it out. If I leave it like this, it's going to save it, but it's going to make the corner 0, 0. Okay. So what happens if you want to? Because this happens a lot. I want to open up a raster, change things. The raster that I save out, I want it to have the exact same cell size, and I want it to have the exact same lower left corner. So if I knew that, I could just put it there. But wouldn't it be better to ask this raster right here what its lower left cell size was and all that? Yeah, it would be better to do that. I'll wait until for a few seconds until you're done there. Typing that up. If it's not running for you, y'all could send it up.
Mine's working.
I think there's a call coming in on the IVN system. I don't know what to do, but I guess we'll just ignore it because there's a class. Yeah. I'm sorry, what did you say?
Yeah.
Okay,
Oh,
you got an error?
yeah.
What's your error say?
Line 11, which is my file save. It says, no attribute, W original raster, I see. A right there, just goes everything off. Yeah. Okay. Right?
That's built in, but
Yeah.
that's like this very long.
Dr. Raver's telling me to spell things right. Good. Shoes on the other foot, yeah. Hey, there it went.
All right, so I've got my my big old my raster here, and I've changed the value. But let's say I want to put it in the exact same position. One thing that I can do is look back here to this help, because this is doing a NumPy array to raster, and look what it's using for the lower left. It's using the lower left of the import raster by using this syntax. And it's getting the, is it getting the cell size? It's getting the cell size from, oh, I just noticed an error in the ESRI help. Right? This just says RAS. RAS hasn't even been created yet. It should be in RAS like these other ones. But in any case, I don't know how they, I mean, you'd think that they actually try to run this code before they show it, and that wouldn't run. There's no, RAS isn't. What's that? All right, so another thing that we have to do that they did is, in order to actually ask the raster for its lower left corner and ask it for its mean cell width, we have to make it into a raster object. So I'm going to copy all three of these lines up here and paste them here where we have ours, and then copy my little line here. One thing that I forgot to do is type in R right here. It's not totally critical, but let's say you have, you're using the slashes to run this way, it would give an error. Try to run that. Oops. Okay, I got an error. Oh, look, I got an error. I got the error I said I'd get. See that? Told you that was an error. Silly ESRI. And I'm like,
Fire tonight.
I know I'm not messing up quite as much as usual. All right, so that's going to run. So what happened? What did this scope do? Just as a review, like you can say it all in really succinct sentence if you want.
Dr. Aaron?
Yeah.
I was just about to ask you, drag that window a little bit to the side where we've got a black bar in the beginning of the code.
Is that better?
That's better.
All right. Okay, so if I was to summarize this, I'd say that it opened one raster, it changed the value in the third row, or sorry, the fourth row, first column, to a 0. Okay? That's really all it did, and then saved it out into a new raster. All right. I'll just keep that up for a second. But when I open this up in ArcMap and I toggle back and forth between my random raster 4 and my random raster 5, you're going to see that cell change values, but all the rest of the cells are going to be the same. Okay.
That one, the lower left, ArcPy, does it end with that Y min statement? How does that line of code end?
Oh, yeah. Yeah, let me make it big. Oh, that was actually almost the end.
Okay.
So what this is doing is taking this raster object and asking it for the extent rectangle for the bottom X and the bottom Y. And then it's asking also for the cell width. Oh. All right. Probably because I was thinking too highly of myself tonight. I also forgot to actually append this in there. I'll append it all. So that goes right here. This can't be can't really be two lines like that. Python doesn't like that. All right, so you still have to feed these variables that you just created, the lower left corner and the cell size. You created those variables, but you haven't actually thrown them in to the numpy array function yet. So that's what you're doing here, is you're giving them the lower left. What's wrong? I got a problem right there. It's okay.
Okay, that's fine.
But what's wrong with ARR?
You need a dot or something?
It's a comma.
Oh.
There we go. So now I gotta run this one more time. I'm gonna go back here. Oh, syntax error. Oh, extra parenthesis. Run.
I got it there.
What's your error say?
Let's see, line 6 in module, lower left equals ArcPy dot point, in RAS, extend xmin, in RAS, blah, blah, blah. Attribute error, object is known, attribute
That's what it was spelled.
Okay, so the line above it is probably not correct. So this line right here, there's something different about that line, probably. Because what's happening is that in RAS isn't becoming a raster. And so maybe this location doesn't exist, or it's not being referenced correctly. Like is there, make sure there's something at, I don't know what path you used on your computer. Like where did you save my random raster for? Where did you put it?
I put it in C10 for my random raster, just like you have it.
Okay. And it says arcpy.raster.
Let's see.
I forgot the other advantage to this. The really cool advantage to
Oh, there we go.
doing this is that this does, none of this requires a spatial analyst license. So like if you didn't have spatial analyst, you're good. You can do all sorts of things. So there's a function called numpy.where. Numpy.where does almost the same thing as con in ArcGIS. So you can replicate that ability. So I'll modify my.
There's some types of errors.
Okay, what's there now?
It's where it says lower left equals, it keeps highlighting lower left now. Although why? Oh, never mind.
Yeah, so usually when you get a highlighted, it can't read that, and almost always it's because of a line above.
Close out parentheses or something.
Yeah, it's working now.
Cool. All right. So I'm going to show you what I'm talking about here. So numpy where. Okay. So numpy where returns elements from X or Y depending on condition. If only condition is given, returns condition non-zero. That's a lot of gobbledygook. Let's see if I can. I'm just experimenting for a second. So I'm going to save file, save, because this example works. Save as example 3, hold on. Oops. And instead of doing this part, I'm going to, let's say this is 6, and say ARR, numpy dot ARR, or numpy dot where ARR is greater than 75. Think that'll work? Yeah. What's that?
My son, my wife
Oh.
sent me a picture of my son, he's sitting on his little potty. Reading the newspaper.
Awesome. Okay.
So proud.
So I just demonstrated how this con operator is almost the same thing. I mean, the where operator is almost the same thing. So I've got the array, and what I did was I put this numpy.where function takes a condition and returns this value if it's true or this value if it's false. And so everything that is
Greater than 75 stays. It's less than 75 gets replaced by.
yeah. So this is the value if true, that's the value if false.
Right.
Yep. And I saved that as random master 6. So let's go take a look at all these guys in what's that? I'm gonna pose this for a second. What's that?
Jackson overrode number 5. She didn't say it was number 6.
It's okay. You could just well, I'll post both of these on GitHub, and so you can get them. None of these are part of the lab. We're still on the. We may spill over into next week, which is okay because we're talking about Python. So I'm going to look at 4, 5, and 6. Okay, so we're talking about external modules next week. So this is 4. Oh, because it's yeah, random numbers. Oh, you know how you can do? If you go up to symbology, you can say to import and say that you want to change it to the other one.
All right, don't forget that. Yeah, only the Colorado wants to recognize it.
So then you can say, I want to use 4 in all of them. So I'm going to take 5 and change it to 4, and I'm going to take 6 and also change it to 4. Of course, yeah, 6 is going to be 4. Okay, good. I think I already did that one. So now they all have the same colors. So this is 4. If I turn 4 off, it's the same.
I think because with 4, 5, and 6, you just do like little small things, change to like you're replacing.
Yeah. Okay, so I'm going to say all layers. So we can't see it in the colors, but if I hit this button, I get 66. Yeah. Yeah, there we go. So this one right here, I get 93, and then I get no data. The reason why I get no data, this was the column. It was 0, and we said the zeros were no data. So it turned it into no data. But I don't know why I'm not getting any I'm going to close this down for a second. Look at my code here.
Those three were the same.
This right here doesn't say out. So now this will work. Because I created a kind of second temporary array right there. I didn't change it. Okay, so now back open to ArcMap. Now if I open up 6, it'll look like that. All right, we'll end here in a second. I'll sum everything out and tell you what the assignment is, and we can do some of it next week. Okay, so 6 looks like this. Yep, and
this is a bunch of no data now. Okay.
right. So we basically assigned everything out as everything that was less than 75. We assigned out to no data on that one. Now, if we didn't want to make it no data, if we wanted to actually leave it 0, we could just change this value to no data to like -999, and then we wouldn't get any no data. Because, yeah, we get actual zeros instead of no data. Sorry. All right, cool. All right, so okay, so the assignment is to go back to this script, and it'll probably actually be easier to go back to last week's script, or at least the script we charted at the beginning of class. So what I mean is eventually you're going to make it into a toolbox too, okay? But you want to get it running outside of a toolbox. So you could just delete. Let's do that right here. So that's not the class. Okay, file. Recent files. It's this one.
991 number 9.
Yeah, it's this one right here. Okay.
I still get parameters text.
Yeah, I don't have it though because I created
You
it,
saved over.
then I saved over it. Yeah, because I said, oh, we're eventually going to turn this into a toolbox. No, it's if I roll back, then it'll go, but then it'll ruin everything. So I'm changing all this back here really quick so that there'll be a version. But I'm going to call this file save as. I'll call it 10.2. And call it res. Yeah, and then instead of output location, I'll just put total.img. Okay. So you don't need to do this. I'll save that all up under the GitHub. So now this would run the way it is. Let's just test it to make sure. Close down our catalog really quick. Close down our GIS. See if this runs. Okay, so the assignment is to take this. Now, Euclidean distance is one that is probably because it's still open somewhere. This should work. I'll upload. I'll make sure it works. This line of code, that's hard to replicate without a GIS. You can replicate that in some open source software, but it's beyond the scope of this course. We did it one semester, but that semester we tried to cover too much in this class. So we got this we're going to have to leave. But after you create this Euclidean distance data set, so everything below out Euclidean distance, all the way, including this part, what the assignment is to modify everything below that so that it all does it in NumPy instead of doing it in ArcGIS. And then we're gonna see if my statement is correct that it takes less time. Okay. So we're gonna do this, and this all in NumPy.
And also need to leave the import NumPy.
You need to import NumPy at the top.
Yeah.
Yep. And then we actually don't even need to save it out anymore. There's no reason to save out all these intermediate data sets because in NumPy we'll be able to add them all up later. Okay. So there will be a little trick to the loop, but yeah, we can cover that. Let's cover that next week. So try to see how you would formulate this in NumPy. Try to see how you can formulate that this week. Okay, so go through that. The first step is to take out Euclidean distance and convert it into what? An NumPy array, right? Using raster to NumPy array. And once you have that, it's all math. So you take that array and you take 1,000 minus that array, which the syntax for that will look almost exactly identical to that. And then you are going to have to do something right here. So when you convert it into a NumPy array, you're going to have to give the no data values something. And what's kind of interesting is that you can't give them zeros, because if you give them zeros, when you do the flip around, the zeros will zeros will have 1,000, which is a risk of 1,000, meaning they should be right next to the object. So that won't work. So you got to give your no data values a special value, and then when you do the flip, they'll have the flipped value. You need to say that value now convert it to 0. See what I'm saying? All right, and then you don't need to do the save. So then what you need to do is create each time through the loop, you need to be adding it up. You need to be creating kind of like a sum of all the cells. So that'll be weird because you'll have to initiate an empty raster, or maybe create a second loop. That one will be a little more difficult. But maybe we can talk about strategies for that next week. The point is, you won't have to do this eval statement or anything like that. Well, some of it. So that'll be the assignment. I'll go ahead and, actually what I'll do is just say, instead of this, change everything from here down to NumPy, and then change result back to raster. What's that? All right, yeah, so raster to NumPy raster. Okay, so what I'm going to do now is, so we got all these examples that we came up with. I'm going to uncheck this one because this is just something I was working on to make sure that it worked for the class. And then I'm going to call this after class. Sync. All right, so that made it up. Looks like, yep, synced. And I'll add the YouTube videos here in a second to the page, and then post it one more time. But the code's all posted now.